You're going to hear from myself, Tom Collins, DVLA. You're going to hear from Fahad from the ONS and Paul, who's from Powys Local Council. Right, so to begin with, we're talking about AI coding assistance within government. Whilst individual organisations have adopted the tools independently and at different rates, there's also a centralised effort within government to increase the adoption of the tools. And part of this has been a trial organised by GDS, which ran from November last year, where over 2,000 licences were issued to government departments. At the DVLA, we took part in this, and we had licences for Copilot, Q, and Gemini as part of this programme. There's a really good report on the success of the pilot. You can go, it's on GovUK. It's got lots of data about the trial, lots of statistics, lots of stats about the benefits and that sort of thing. Personally, for me, I much prefer the sort of subjective assessment of things, and the two things that stand out from the report are developers not wanting to return to pre-AI coding working and enjoying their jobs more. If you're somebody who do love statistics, don't worry. Fahad is from the Office of National Statistics. He's going to be covering that in a lot more detail than I can. So in the DVLA, I'm going to talk about how we've adopted AI coding tools over 18 months and the sort of maturity journey we've been on. We actually started our internal pilot around 18 months ago in late April 24. We also joined the GDS trial. We've got around 200 licenses in use across Q Developer and Copilot. When we brought the tools in, we initially started with a small group of users, and the early impressions were this is magic. We'd never really experienced something like this. You're working day to day and these amazing magical things are happening. It was very impressive, but not perfect, right? These things weren't always right. And we also saw a lot of skepticism, maybe a bit of fear from some of the engineers, and there was a relatively slow adoption initially. The other thing we observed was the sort of ambition at the beginning was quite small scale and quite limited ambition in terms of what the tools could do. And the sort of things people would do, these not going to be a surprise. I've got some code, write me some tests. That's fairly standard. We'd have people who don't like creating Docker files. You can ask it to write a Docker file, and it'll quickly, quite easily do these quite simple tasks. There were a few more interesting examples. So people maybe pair programming would use the tools to explain concepts. And if you're doing that whilst working on some code, the tools can actually take the context of the code you're working on to explain a topic like scope in JavaScript. It's quite interesting. We also saw some examples of using the tools for the analysis of real issues in production. In this case, the tool was able to review a poor performing database query and propose an optimization, which is pretty cool, but quite a basic example. To support the use of the tools and try and get the organization to a better place in terms of adoption and our ability to use them, we set up a AI coding assistant group. This is a really active group. We meet once a week, every Friday, share demos and ideas and talk about new features. It's also a really active group across the organization in terms of our Teams chat, and there's kind of daily people are sharing, have you seen this new feature, new model? Look at this framework, look at this toolkit. It's a really important part of adopting the tools and gaining maturity as an organization. There's a really nice quote from Dave Kirk, CGI, one of our partners, where he says, "It's like being back at the start of my career, all the innovation and sharing of ideas. It's been a while since I felt like this." And that's a really nice quote that sums up the fun and excitement that's grown around AI coding tools. So the journey of maturity in the DVLA, when you first got the tool, if nothing else, it gave you a fancy autocomplete that could try and guess what you wanted to write next. If you went beyond that, maybe you could ask it to do a sort of one-shot code change. And that was pretty cool. It didn't always work because the tools were fairly primitive at the time. But you could try and ask it, write me this feature, and it would have a go. And things remained like that until early 2025, when most of the tools started to release agent modes and support MCPs. And this was a fundamental shift in the capability of the tools, which opened up more complex ways of using them, provoked greater ambition within the engineers. And this was really like a rocket boost to what you could do with the tools. What followed from that was people starting to adopt structured workflows and trying to control the agents and make them behave in a way that suited their sort of engineering approach. So what we're really seeing is being able to adopt engineering practices rather than hoping that this magic tool would do the thing you want. And this brings us to where we are now, where we're looking at establishing AI coding standards and best practice, and really looking how can we make the tools write sort of production-ready, clean, maintainable code that meets our sort of organizational house style. Continuing this theme, it's useful to look at this as a timeline. So we can see here, over the last 5 or so years, there's not a lot of activity on the left. Once GPT-4 came out, then we start to see a massive acceleration in frequency and the sort of number of new models drop in that are far more capable. If we then layer in the development of the AI coding tools on top, we can see whilst Copilot's been around, it wasn't really until it got GPT-4 and Claude that allowed the agent modes to be built on top of the tools, support for MCP, and we get this cluster of activity really in the last 12 months. And then if you look at the developer level on top of this, in the community, we see other coding tools like Cursor being released. You also see patterns like vibe coding or the emergence of standards and toolkits like agents.md, which are emerging industry patterns for providing more robust control of the tools. Within the DVLA ourselves, we started looking at them in our tech lab. We ran a pilot, we set up a working group, and we're now looking at how we create standards and best practice for making the tools engineer code that meets our style. So with all of this in place, agents and for more capable models and agents, around April 2025, we started to see a big change in what we were able to do. Got some examples. This is a nice one. We had a production issue to do with EKS scaling and spot instances. Chris Williams, one of our engineers, asked the Q developer CLI to try and help him with this issue. He expected it to give him some suggestions. What it actually did was ask him permission to run the CLI itself. It went off, it queried the cluster status and various API calls, and actually came back with a diagnosis of the issue and told him how to address it. This was a big change, right? He wasn't expecting this to happen, but the tool was able to use other tools to answer this question with real data and fix a production issue. It's pretty cool. This is probably my favorite example. So one of our engineers, David Ferguson, likes to call the AI coding assistant the genie. These are real photos of David. Sorry, David. And David's a huge fan of test-driven development. What he wanted to do was make his coding agent apply a sort of red-green refactor cycle. So out of the box, it's not something it does. This is an independent thing that David did off his own back. He configured the tool with custom instructions, told it to use the red-green refactor pattern. He was then able to interact with the tool via the CLI. It would write a failing test, assert that the test has failed, write some code to make the test pass, and then refactor. It seems quite simple, right? Why wouldn't tools do this? But this is a really, really powerful example of how you can apply engineering practice to the sort of magical tool and make it behave in a robust and more scientific and engineering-led way. We've also seen on the other end of the scale, we've seen a rapid acceleration in the amount of sort of vibe coding type prototypes. So these are typically for internal tools. And it's fairly routine now to see an engineer build something like this in half a day using an agent. In this example, we've got a custom dashboard for our OpenSearch cluster that shows the sort of metrics that are meaningful to us as an organization. Here we've got a tool we built rapidly, again, in half a day, that scans all of our external hosts for security headers, CSP policies, that sort of thing. This sort of thing, we probably wouldn't have built it without AI. We could build it, but it would probably take, an unnecessarily long period of time to build and test. With AI, it's reasonable to build these things rapidly and get them deployed, in days. It's pretty cool. The other pattern that emerged is plan-in mode. So this was a plan-in mode prompt shared in our working group by one of our engineers. I took this and ran with it, as did others. What this does is allow you to request a feature. I want to build this thing. Enter plan-in mode. The agent would then ask you 4 to 6. Well, it would look at the code, ask you a bunch of questions, well thought out questions about what you want to do to sort of guide the design. You could provide simple answers. It would then create a plan in a markdown file with implementation steps. You could then ask it to do step 1 of the plan, and it'll update the markdown file. You can come back to it later and do further steps, review the code, that sort of thing. This, again, we're moving from hoping the genie will do this, magically create the feature you want, to applying a structured approach and a bit more of a sort of scientific engineering-led way of doing things. Quite quickly, these patterns, rather than being a custom prompt you run, we're starting to see things like Kiro and SpecKit, and there's a number of frameworks emerging that are trying to do this sort of structured way of working, and I think this will be really important in the future. Wasn't all amazing features and vibe coding. Along the way, a few things got a bit more complicated, so once you start using complex features, you're using far more credits and making more calls to the agents, to the models. The tools that we're using, particularly Copilot, introduce quotas, and engineers now need to be, aware of which models they're using, how much they're putting into the context, and how they're using their quota. This is a skill we're still learning to develop. And it's not uncommon now for engineers to burn through their quota, particularly people who are heavy users of AI coding assistants and using more of the advanced techniques. It's quite common for them to burn through their quota early in the month and then sort of fall back to lesser models. So this is the skill set we're going to need to develop. So on to something more serious. The examples I've given so far are examples of individual engineers taking it upon themselves to use an AI coding tool to do a thing, which is great. But I think in the future, there are other ways of working where we can, have a more structured approach to using AI through the software lifecycle. And most of the things I've shown, they're kind of trivial internal tools or aspects of a bigger solution. So we wanted to run an experiment, and we were interested in, can we make the tools produce higher quality code? Can we apply the tools systematically at a team level? And can we use it for more than just writing the code at the end of the process? And a few months back, there was a project that came along that was a really good fit. This is a serious project. This isn't an internal tool. What we were dealing with is a new component that would take daily batch files from our driver's mainframe for processing reminders. So these are things like notifications that you need to renew your license. So they're quite very important to our business, and this is a critical, serious service. We needed to build a new action processor component that needed to call our notifications utility, which could then decide whether to print email or SMS the customer. We wanted to use AI to experiment with the way that we built this component. So typically in the software lifecycle, it looks something like this. You have a normal backlog, you do refinement, you've got a sprint. If the piece of work goes to Pip, who's an AI super user, we'll use AI. If it goes to Vic, who maybe doesn't use AI, we won't use AI. Right? And that's okay, but it means we don't have a lot of control over how AI is applied to the way we build things. We adapted our process to use this approach where we armed all of the engineers in the team with the same AI coding tool and agreed to use an AI-first approach to developing the solution. So once an item was picked up for work, we'd generate a product requirement prompt. Humans would refine that prompt. The output of that would be an improved AI-suitable prompt that could then be used to try and more deterministically produce high-quality code. This is how it fits into the overall flow. So the green boxes represent normal non-AI activities. The orangey peachy type boxes represent where we're using AI and doing refinement of the PRP. Again, it's a human peer review at the end because we really care. It's the product requirement prompt. We take a ticket, normal work item. We get an AI coding assistant that's been configured to use our AI coding standards. We have a product requirement prompt, which is a reusable prompt. We feed all of this into the agent. The PRP prompt is told that it can use an MCP, so we can go off to Jira. We run all of this. The agent goes off to Jira, gets the ticket, looks at the standards, and generates a PRP. In this, there's a detailed breakdown of exactly what needs to be done for the piece of work. It'll include technical details, description of the work, gotchas, what the code will look like before and after. We can review this, make sure it meets our idea of what this piece of work needs to do. We can then feed that into a developer with a coding tool and hopefully produce high-quality code. Sounds great, and in theory, this is a better approach than what we discussed earlier. There's one problem. It's this one. So we've got really good developers at the DVLA. We've got a lot of experience writing Java code. We've got a house style. We like clean, maintainable code. We care. These are components that will be around for 5, 10, 20 years. We'll need to maintain them and they'll need to evolve. We really care. We put a lot of effort into writing standards for the AI coding agent, detailed standards across all of our tech stacks. We're battling with an LLM that's been trained on the masses of code from hundreds and thousands of developers from all over the world. Our standards are quite detailed. They're not perfect. It's a skill we're learning. Problem is, the output, even with this sort of engineering approach, the output doesn't quite meet our expectations. So this is the initial PR to bootstrap the project. You can see there are 35 comments and a huge amount of overhead created by trying to just get that bootstrap project up to scratch. Examples of the sort of problems we have: we like to use annotations, the code didn't, and someone's got to go in and clean that up. We've then got to go back to our standards and improve them to try and control the AI to not repeat that sort of mistake. So it was an experiment. So yes, it was a success. Few things we learned. We don't want to roll this pattern out at scale across our organization. I don't think the tools or our engineers or our approach is ready yet to do this at this sort of scale. I think we'll get there, and I think things will improve, and I think it's something worth aspiring to. There was a huge human cost. Whilst we were able to produce high quality code and had some great examples of success for a serious project, the sort of things we found were creative loss for the engineers, huge drain of trying to use AI, and still a significant amount of human review required. One thing we learned: don't AI everything. Initially, the team were trying to use AI to do every single thing. There's a discernment as to whether, should you use AI for this task or not. We know we need to develop the skills to produce standards and best practice to work with AI. And that's something that how we do that and share that across the organization is going to be an ongoing challenge. PRPs are useful. And I think to size stories for AI is different to how you'd size stories for humans. Probably smaller is better for AI. I think in the future, we'll end up with something like this where we're able to apply AI across the entire delivery process. So there's tools like Rovo that are being built into the Atlassian tool set. It's really how can we use AI across the entire life cycle and use frameworks and standards to maybe remove processes like the PRP. Which I think is great, really useful for us to aspire to. Good news is we still need humans. Our engineers are really important. We're not going anywhere yet. I think the future is really how do we improve our skill set to work as the tools continue to evolve, to be able to make better use of AI to sort of accelerate how we build things. That's all from me. Quick plug, come and work at the DVLA. We're currently recruiting for cloud engineers. If you'd like to come and work with us, speak to the guys at the stand at the back. Cool. Thank you very much. And I'm going to hand over to Farhad.
Hi, everyone. Good afternoon. So it has been really inspiring day so far, and hopefully you will learn something good from this session as well. So my name is Farhad Anwar. So today I'd like to share our story, how we have embedded software engineering AI practices within the ONS. And the whole idea is not about that we want to increase the productivity or save time. It was more about empowering the software engineers. And the key thing was that we want to reduce the cognitive load from them, so they have more time to solve the business problems. So that was the whole point. So in this session, I'm going to cover two areas. One is about our journey, how we started, what we have learned so far, and hopefully you will get some useful information from it. And later on, I'll also discuss what are the things we have done to see what is the impact we are seeing in our organization, to the software engineers, but also to the organization as well. So going into the journey itself, so we start with the lightning talks and a lot of awareness. So that was the key thing. We just don't want to give AI sister tools, more specifically GitHub Copilot, to the software engineers, say, yeah, you just start using it and practice and start using it. The key thing was for us is to create that awareness. And it's not only the software engineers we want to create awareness, but also the other people who are involved. For example, product owners, BAs, data scientists, data engineers as well. So we invited everyone to this lightning talk. So the whole concept was to create that awareness. And that was the key thing. And not only the lightning talks, we did a hackathon as well, because we like to know how we can use GitHub Copilot for our specific needs. We have a lot of legacy code in SaaS, and we want to see how we can use GitHub Copilot for that purpose as well. We started the trial, but again, the key point was that we did involve security, data ethics teams as well. So the whole point was that we are moving towards the full rollout, but we want to create that whole environment. We did a review session there as well, and then we roll out. But the key thing before we roll out is we spend a lot of time to create a policies and governance. And we spent a lot of time with Microsoft GitHub to create this due diligence document and FAQs, detailed FAQs. And we have shared this with the civil service department as well, so that it can be useful for them as well. They are in public repository, so if you want to use them, you are more than welcome. And for the impact side of it, both qualitative and quantitative side, we focus on it. From a qualitative side, we use space framework-based surveys to understand what is the kind of a developer experience. And on the quantitative side, we use GitHub APIs to create dashboard to understand actually how people are using it, how software engineers, data scientists, data engineers are using GitHub Copilot. So throughout our journey, the key thing I like to share with you is that we understand two very important parts. One is that this AI awareness is not a one thing. It's not a one-time thing. It needs to go again and again, because we are rolling out to other people as well, but also we want to ensure that the new features which are coming, we are sharing with the AI literacy on that one. The other key thing is about the governance and data inside as well. They go in hand in hand. And we spend a lot of time regularly reviewing our policies, our dashboards, and looking into the data and taking proactive actions from it. So the two key takeaways I want to give from this talk is from our journey is one, this AI literacy is like a rhythm. The more you are into the rhythm, the more benefits you can get out of it. And it's important that you don't see that you have done the first time lightning talks, awareness hackathons, and that is going to work for you. It's going to keep on changing as the new features are coming from GitHub Copilot, but from other AI-assisted tools as well. And you have to keep doing this kind of awareness and AI literacy more and more. The other second thing I'd like to share with you is data-driven insight and taking proactive actions. So I'm going to go a little bit deep later in the slides, but the key point is that it's important to see how the people are using your these tools, GitHub Copilot tools, and then see based on that one what you want to change in your AI literacy, what kind of activities you have to bring in, so your organization get better and better in the use of GitHub Copilot, but any other AI-assisted tool as well. Next, the real part is the results, is what we are getting out of this use of GitHub Copilot or AI-assisted coding itself. So we started to capture data both from qualitative and quantitative side of it. As I mentioned, for quantitative side, we use GitHub APIs to create this dashboard and get the whole insight of the data. And for the qualitative side of it, we use a space framework-based surveys, which is commonly used in the industry as well to understand the developer experience. Now, in terms of the quantitative data, we have currently around 200 users who are using GitHub Copilot, and around 80% of them are using quite actively. And we are reviewing this on regular basis. There is automation going on. If the user is not using for more than a month, then we take it away. So it's important that in a public sector that you get maximum out of the investment you are spending on it. And in terms of the data we are getting, so we are getting the data, how many suggestions are created from a GitHub Copilot, how many of them are accepted. That is a really important element. But we also get the insight about what languages are used by the software engineers or data scientists or data engineers, what ID they are using it. And all this information is really useful to create this AI literacy more and also have a proactive action in terms of governance. The GitHub itself gives you only 28 days of live data. So we are also storing the historical data. So we have now data for the last 1.5 years. And this is important because it gives us the trends. And based on that trends, we make a kind of a strategic decision and also go back into our governance or policy and tweak it so it gets better and better. The other key thing we have done is not only organizational level data, we are now storing the data on team level as well. And we are sharing that information to the team as well so they can take their own proactive action as well. So some numbers here. So this data is from mid-2024. Then we started collecting data. So about a million code suggestions have been generated within ONS, and 250,000 has been accepted. So that gives us a kind of acceptance rate of 26%, which is a little bit low than what the industry says, which is around 30 to 40%. Some claim even 50% as well. But for us, 26% seems to be all right, because one of the key things for us in a policy is that we are only saying that you can use only the GA features or general availability features, and not the public preview or experimental features as well. So 26 seems to be all right, and that shows in our trend as well that it's between 25 to 28% over the last 1.5 years. In terms of lines of codes, we are talking about around 1.5 million was generated and 0.3 million had been accepted. So that's some data for you. Now I quickly go through the qualitative data as well. So that is based on space framework-based surveys. So that some of the information I'm sharing from the last two surveys. So the adoption has been increased from 78% to 89% in the users of GitHub Copilot, and this is including the data scientists and data engineers, some statisticians as well. And it also shows the investment we are spending on our AI literacy work is showing benefits. Consistently, we are saying overall benefit seen by the software engineers is close to 4.26 out of 5, which is quite good. And in terms of around 50, from the last surveys, around 64% of the users are saying they are at least saving around 1 hour per day using the GitHub Copilot. If we round the whole numbers, we are talking about around 17,000 hours saved annually. And that hours are available to solve the real business problems. And more importantly, 1% of the software engineers saying they will be extremely unhappy or very unhappy if we take away the GitHub Copilot from them. That shows that it is part of their embedded workflow. It was really interesting to see how different software engineers, in terms of their experience using GitHub Copilot and what they see the value out of it. From early developers, we have a lot of apprentices and young developers. They see it as quite a lot of confidence booster. So they can use that information because they have access to the knowledge very quickly. And also they see it as a learning accelerator as well. So that is the main benefit they can see. The mid-level developers or software engineers get maximum out of this. And they see from a prototyping and also unit testing kind of a repetitive task, they use GitHub Copilot a lot. When we look into more senior level engineers, they are using for debugging and boilerplates or scaffolding. But the key thing is also they are the ones who are also sharing risk involved in it. For example, over dependency on GitHub Copilot or not following the kind of coding standards. We are now spending time to see if we can use GitHub Copilot spaces to involve to have better standards, our own standard embed into the suggestion Copilot is generating, GitHub Copilot is generating. So this is really fascinating how different kind of a software engineer at different levels seeing the benefit of GitHub Copilot. So the two key takeaways from here, from this kind of a qualitative and quantitative data is, one is this acceptance rate is a real important thing, that how much code suggestions are generated and how much of them are accepted. Because if it's too low, that means you need to spend more time on AI literacy, that the users are not using GitHub Copilot or AI assisted tools enough and not properly using it. So it might be more training is required, more awareness is required. The other key thing is if it's too high, then it's a red flag. But that means the users are not giving enough kind of a time to look into the suggestion, just accepting it, which is a red line, because that means they are not reviewing it properly. There's code reviews are not going through it properly as well. So this is a really important kind of a numbers or a metric which you can use in your organization as well. The other element is that all dashboards and data you have, it's important that you make it available at the right level as well. So we are making it available to the teams level as well, so they can see actually within their own teams what is the acceptance rate, how the users or the developers are using GitHub Copilot, so they can take their own proactive action. It might be more of a literacy side, or it might be more of a governance side, so they can make their own decisions as well. Of course, privacy is the important thing. So there is no data linked to an individual. At least you have to be a 5-member team to get this data. And also on the organizational level as well, these patterns, historical data is important, because as we are moving forward and we are making it available for other users as well, which are not classical kind of software engineers, but they are data engineers, data scientists, and other business users as well. You see what is the trend? Is it trend in terms of acceptance rate or using or different language? What kind of a trends you are seeing? And then based on that one, you can adapt your governance and also on the AI literacy side as well. So in terms of the future, what we are planning to do in future, one, of course, we are spending a lot of time to see the latest feature like GitHub Copilot agents, code spaces, also knowledge base as well, and how we can implement standards as well. I've been involved in working with the UN to see how we can create a kind of a custom models as well for statistician side of it as well. So that's something we are looking into it. But the other key thing we are starting to look is how we can use AI through the SDLC. And this is where we have seen there was a real big value we are saying, because we have involved all the stakeholders of software engineering, from product owner to BA to architect, everyone, because now they are starting to use AI for their own benefit as well. And so we want to implement kind of a AI benefits throughout the SDLC process. And one of the first thing we are looking into is see how we can use content engineering for that purpose. And the first thing we are looking into it, rather than creating fancy requirement documents or creating architecture documents in different formats, because different personas have different kind of needs. You're saying, can we use just Gen AI and use the English as a main standard of storing all the information, and then translate that information for different personas? For example, you have a requirement gathering in a simple English, and then you can ask, with the help of AI, you can create a Gherkin styles, user stories, or you can create a UML diagrams and convert it back into a simple English as well. So you can then discuss with the end user as well. This is the implementation of it as well. So that's one thing we are really looking into it. Also, in terms of the metrics, I talk about qualitative and quantitative metrics, but now we're really looking into is how we can link this with the business value as well. So I have been exploring the concept of business value tree. You might have heard about it, but every activity, all the initiative we are taking it in generative AI, we are saying how it is linked kind of a business value, how it's linked to the what we are trying to do at a business level. So that linkage is important, and that's the key thing to deliver. So at the end, one final thing I want you to take away from this talk is that in this new paradigm of software engineering with AI system, there are two forces which are basically playing a big role. One is a lot of push from changes, different changes coming from different angles. And the other thing is that we are trying to pull a lot of information, because on every next day there is a new thing in AI, and we are trying to learn that one. Now the key balance thing is to have a balance in terms of to get the maximum kind of a benefit of it. So the key takeaway is not try too hard, not try to burn yourself and say, I want to learn each and everything, I want to implement each and everything in your organization. The key thing is you get maximum out of what you're implementing that one. So don't go for all the shiny things. See what you can get maximum in terms of business value before go to the next thing. Now, software engineering is evolving and it's going to change. Software engineering becoming more of a custodian, more and more business user will be writing software engineering. It's a really exciting time, and I think we are fortunate to see this shift. And so we should be all enjoying it rather than thinking how to stop this, right? Thank you very much for all your time. Thank you.
Hi everyone, my name is Paul Fennell. I'm from Paris County Council. So the title of my talk, which is going to be short and sweet, I promise you, is from low code to full stack with some AI assistance. We're a bit different, I guess, from a lot of what you've heard today. We do a little bit of serverless with Azure functions, bit of containerization and stuff, but our architecture and our stack is going to be quite different from what you'll have heard about today. Any local government folks in the hall today? No, I'm the only one that. Okay, so I'm going to very quickly talk about who we are and what we do and how we do it, and then I'll get into the main substance. And yeah, we've heard a lot about Gen AI today and vibe coding and so on, and it's going to be recapping some of that, reprising a little bit of what we heard from Dimitris at the beginning of the day, and also talking about. I guess I've kind of got ahead of things a little bit in terms of what he was talking about. You mentioned coming after the architects. I kind of done that to myself because that's part of my role, ahead of even really what we've been doing within the development team. And then getting into a bit more about, well, where are we now with all of this and where might it be heading? And That will be tying together some of the stuff you've heard throughout the day, really. So who we are, a really small team, 10 of us, all generally cheery, it has to be said, a senior developer, some mid-tier developer integrators, and some assistant developers, internally recruited, largely from within the organisation. What we do is typical of local government. We're really busy. We have lots and lots of different things to do, lots of different line of business applications. Appreciate this is a busy slide. You're not going to be able to see what it's all about here. I'm assured you will be after in the recording when that's put online. But basically this is saying we've delivered 38 projects since the beginning of the financial year. We've got a lot of stuff in flow at the moment, including 5 major systems implementations in HR, finance, social care, regulatory services and housing. How we managed to have all those contracts hit us in the same year, I'm not too sure. Maybe we'll try and avoid that in future. So we work with a whole load of different line of business applications, and our team's job is largely to integrate those where we can, preferably with APIs if they've got them, and might default to RPA and things if we have to. And where there are gaps in all of that offering within the commercial market, we'll fill those gaps with bespoke solutions. We work with a load of technologies similar to what a lot of you guys will be working with. So we've also been doing quite a lot of work with Gen AI, and actually probably done more actually building Gen AI type solutions and prototyping them as proof of concepts and even putting some into production before we got into using it as part of how developers develop. So there's a list of our projects that people can refer to afterwards. I've highlighted in bold the ones that I think are particularly novel or likely to be of interest and are kind of actually out there doing things in production already. How do we do all of this, and how do we organize ourselves within the team? Well, we decided that actually we needed to take control of our own destiny and apply some of what we do for the rest of the organization to ourselves in terms of how we set ourselves up. So this is the entire world of our digital innovation team and our program management office in one slide. So again, lots of detail, quite complicated. The core of it, though, is a set of bespoke adaptations within Azure DevOps. So we basically did some analysis of what our needs were, and across our project management team, across our business analysts and our developers, and then built that for ourselves within that core within Azure DevOps, and then did some stuff either side of it within mostly Microsoft technologies. And latterly, the team have decided actually they're more than ready to move away from low-code, no-code type stuff wherever they can. We'll probably still have to do some of that when it makes sense within Power Platform and SharePoint and so on. But they said, no, we want to do real stuff. We're ready. And I said, okay, what's your stack going to be then? Come up with it and decide what it looks like. So they did. It looks like this. It's containerized. It's Next.js, TypeScript, Postgres or SQL Server, Microsoft Authentication Layer because Enter ID and 3000 E5 licenses and so on. And that's broadly the kind of operating space when we do our own bespoke development. That's how we do it. So getting on to the main substance of this talk and what Tom and Fayed have been talking about already. What's our take on this side of things from a local government perspective in that really small team, doing lots of different things, lots of different platforms and technologies? I guess, first reaction most people have to vibe coding these days is, what's Andre done to us all? The language might be a bit problematic. Are we struggling with actually making sense of this and it not being too hypey and too kind of driven by this inflated perhaps bubble that's going on, driven by Silicon Valley and VC culture and so on? And where is the substance in that? Are we just driving actually velocity in the creation of technical debt rather than value velocity and so on? So I think even Andre's now saying, actually vibe coding is not working for what I need to do for my new product I'm just launching, and I hand coded it all, and I had to. Okay. But yeah, where is the actual value? Where's the signal in the noise, and what works for people? So what our developers are telling us so far is that, yeah, there is some value in it. And that is, first of all, it works really well for small, fast and early work, rapid prototyping, proof of concept, get something done quickly and try it and then scale from there and add the tests and add the standardization and all of the other things that need to come before you actually get into production. But if you're just trying to knock some stuff around within the team, very helpful. But oversight, absolutely non-negotiable. You've got to do it in the right way when you start to scale, when you start to get that stuff out there. So it's definitely been found to be a learning accelerator, particularly for the more junior developers. And it's not getting in the way of them learning, they feel. It's just helping them learn. And going back to that comment made earlier in the day about Hello World, and it's not really Hello World anymore. Nobody really starts there now. They start with getting AI maybe to generate a load of code and then figuring out what it's doing, how it's doing it, is it doing it right, and so on. So yeah, best for proposals and documentation and debugging and diagnostics and rapid prototyping, really. But everyone within the team conscious of its limits and its risks, making sure that they're not running into any pit traps, really. And they all have their own different tooling preferences. So some may be using ChatGPT or GitHub Copilot or Claude Code and so on. And we haven't really standardized that yet and gone properly into what's working well for which use cases and which patterns and so on and so forth. But some of that is starting to emerge. So quick summary, by experience level within the team, I don't think there are any real surprises there. Most senior guys finding, documentation and copy and all of the kind of getting the PRDs and the architecture and all the other stuff sorted out. And on the junior side of things, it's more around the learning and the explanations and little utilities and bits of code and explaining it back to them and so on and so forth. So it kind of confirmed what you might suspect, but it was good to see it played out within everybody's response when I asked them. So we've also done quite a bit of, as I said at the beginning, applying all of this to my role and to the work of the project management office as a whole. And Tom was particularly keen that I talk about this in a bit more detail because he thinks it's maybe a bit more unusual and also maybe also kind of back to front in terms of what you might expect. Maybe most people will be trying it within coding first and then getting into applying it to the project management function and the wider innovation function. So typically a lot of folks will be starting here in the development testing and acceptance and deployment side of things, whereas we're looking at this side of it from kind of discovery and ideation and inception through evaluation and prioritization, and then resourcing and planning to an extent as well. So how are we doing that? Well, typically someone within the organization will approach me or someone adjacent with an inquiry. Can we do this? Or we got this problem. It might be in an email. It might be via Teams message and so on. That goes into the corpus. Then we'll have a meeting. We'll discuss that. We'll have transcript on Copilot 365, Facilitator now, whatever. That will go into the corpus as well. And then we'll generate some additional reflections and different aspects from that content, which also goes into the corpus. We've got templates in there. We've got some standard prompts in there. And through all of that, we can then start generating whatever we need to, briefing notes and requirement definitions and architecture outlines and option papers and business cases, and all depends on the nature of the work, the scale of the job, who needs informing when, with what, and so on. So from there, we also then take it into our proposal evaluation and scoring, which looks at cashable savings, non-cashable savings, strategic alignment, regulatory alignment, and so on and so forth. We've got weightings around that, markdown files, of course, that have the schemas for all of this in them. That gives us something that our evaluation panel can work from, that no one individual is particularly wedded to and then feels defensive about because they came up with the initial take. It's actually something that's got this degree of sort of independence, and largely we don't always agree with it. It's usually about 60, 70% right, and we adjust it from there. What it does do, though, is also identify maybe some benefits or ideas for things that could be better on the justification side of things that we can play back to senior stakeholders, to the sponsors of the work, and say, you're looking a little bit weak on this cashable savings score or this one. And the machine thinks, actually, perhaps we could have a chat about this. You don't quite frame it that way, but you get what I mean. So that can be very helpful, actually, in terms of making sure we've really identified all of the benefits up front, and therefore it's getting the score and the rank that it merits. What does this look like in practice? Well, we've been having a series of workshops around our customer experience framework and what our new customer experience strategy might look like. So to do those, we've had sessions with stakeholders from across the services and from across digital team and our front desk operators and so on. And we sit and meet and have the usual workshops and breakout groups. And we've been using Bean's Magic Note technology, or we could use Microsoft Facilitator or any one of those kind of scripting tools during those sessions to capture the diarized speakers within a workshop environment face to face. And we've also got handwritten notes for the people who don't have access to those tools. They all go into a big corpus, and then we've done some semantic ETL effectively on that to get the data into reasonable shape and bring it into just kind of a standardized layout. And then from there, we've done some thematic analysis and grouping. And then from there, we've done kind of a structured feedback around, going back to the original take on what this workshop was all about and organizing around people and process and technology and so on. What's the playback from all of this that can then inform our future workshops and our next stages effectively in planning all of that work? So that's one example. I think a much more interesting one in many respects, and perhaps a more novel one. Got a project running with our substance use disorder commissioning officer, our lead on that for Paris. And this was his idea actually to work with peers within that group to tell their own story narratively. And they did that via animated videos that they drew themselves and narrated themselves about their experience as survivors of substance use disorder and the effects of stigma and shame and trauma and all kinds of other things that play into that. So those videos are very emotional. They're very effective. They are very much co-produced within that team. And we came up with an idea to how do we analyze all of this in a way that we can actually explain it to people and understand what benefits it's having for these communities, for these people, so that we can learn from it and that we can extend that practice into other areas in a way that's research grade, basically, and provable. Part of that was developed through a conversation with ChatGPT and myself and the substance use commissioning lead to come up with a methodology for it all. It's based on a couple of different academic approaches, one from Labov and one from Reisman. And we created a hybrid because when we looked at the two of them independently, they didn't quite work. When we put them together, they did. So we took the video files, and it's important to note that these video files have text within the frames that's very important to the context and isn't just captured in the transcript. So we used Azure Content Analyzer to against a schema which gave us the transcript, but also any words that could be identified within the video frames, and a narrative impression summary. What's this video feel like? What's it telling us? How's it doing it? And so on. From that, we got the output, that structured output, and we then used large language model against that structured output with a big chunky prompt, which is there, to produce this narrative breakdown of what the video is actually all about in this structured way and how it's doing what it's doing. We took that back to the peer group and said, what do you think of this? Does this sound about right? And they were kind of blown away, as we were actually, that it captured it in a very sophisticated way. And the sort of thing they were telling us was that they felt seen and understood by it in a way that they found kind of unimaginable that AI could actually do. So there's a lot more that could be said about that. It's a really interesting project. We're at the early stages of it, and we can see lots of research opportunities spinning off from it potentially. But the most important thing are the outcomes for the people involved, for that peer group, and then being able to relate that more widely to inform practice and policy. So these are the overall cross-cutting themes across all of that work that's come out. And again, this was analysed from those individual analyses per video. And I think that was picked up in an earlier talk as well, that, working file by file, step by step, and then working across what you've generated is often a good approach to this type of thing. So that kind of takes us on to structuring and scaffolding and how you use that within an AI-assisted coding environment. So I started looking at this initially when I ran across the work of a couple of people at Microsoft. Sam Scilacci, who I think was the lead developer on Google Docs before he moved to Microsoft. He's deputy CTO there now. And one of his team, Brian Crabber. They come up with this whole idea of Lego coding. The idea being that if you're building a great big thing out of Lego, you don't just do it step by step. You'll make a mess. You won't have a clue what you're doing. You get the little component instructions to build little individual bits, and then you start to assemble them all together. So that was their original analogy. They've developed that and taken it into this repo called Microsoft Amplifier up on GitHub, which is pretty hefty, actually. 20 plus specialized agents, whole load of preloaded context. Currently working with Claude Code, but will become more agnostic in future shortly, within a week or two, I think. And it's about the most engineered type of thing that I've seen like this. And we can have a discussion about, I'm sure we will do, whether that's the right approach, whether we're ready for that yet, both in terms of our perspective on things. But they're certainly at that end of the spectrum that Demetrius was talking about at the beginning of the day, in terms of appetite for change. And will we have anybody actually manually coding in the future? And we've got guys here with 30, 40 years experience of coding saying, I'm not now. I'm just building this and it's building everything else for us. Now, maybe they're invested in that because there's a commercial opportunity and Microsoft need to be at the forefront of that. But it's interesting, and I would take a look at it if you want to get deeper into that type of thing. Another thing that I've looked at is a thing called Spark. So specification, pseudocode, architecture, refinement, and completion. Nice kind of structure. Another repo up there. Little bit hypey, little bit buzzy. When I see things like quantum consciousness analysis, my undergraduate philosophy training gets a little bit fight or flight response triggered on that kind of thing. But it's still quite useful, I think, and quite nicely structured. And putting this sort of thing together and starting to play around, we then ran into, okay, so what does this look like in combination? Well, it looks a lot like what DEFRA have done, actually, with their AI software development lifecycle playbook, which I think is great. They're to be lauded for that. And it brings all of this stuff together in a really nice, straightforward, guided repository for how to put this together in a responsible way in a government context. So I think that's likely to be what we work with, something along those lines that we've refined for our purposes. So why? What are the benefits? Well, definitely reusability, clarity, maintainability. Obviously things like agility and velocity and so on. But I think it shifts the validation burden away from syntax into the intent. What are you actually trying to do? And why are you trying to do it? And thereby decouples to artifact-driven development. And if you want to change something about what you're building, you change those artifacts. You change the PRD, you run everything again, you get the product out at the end with the changes in it. So this opens potentially the path to fully agentic and artifact-driven development, emphasizing the importance of standards and observability and testing. Absolutely vital. All of that stuff, of course, doesn't go away. We've heard about that throughout the day. And it still aligns with what we've learned along the way, through the DevOps revolution and now moving into AI ops and off the back of ML ops and so on. So unified feedback loop is absolutely critical there. And it reinforces really socio-technological alignment of all of our methodologies with what our outcomes are, going back to people focus again. So where are we now, kind of as a discipline, as much as we can measure it internationally with all of this? Well, as of last week, because you can never be completely up to date with any of this type of stuff, this is what Sweep Edge Verified looked like and the kind of line of change on it. So if you're not familiar, Sweep Edge Verified, kind of the most trusted evaluation benchmark in this area at the moment, albeit it's only on 12 Python repos, open source ones. So, limited to that extent, but human verified, human in the loop, and very clear changes in its capabilities, and less susceptible to some of the kind of gaming of benchmarks that there is in other areas, I would argue. Big changes in that. The ones I've highlighted in bold are the folks who've really evidenced what they've done and how they've done it in a way that's very transparent and open, which I think is important. So what does it look like from the point of view of a very experienced and quite influential developer? A lot of you will know him, Simon Willison, one of the developers of Django, being very active in all of this area, and kind of speaks really well about the latest state of play and what's working and what's not. And his takes on what I'm kind of calling safe YOLO mode, basically, for an individual developer. He's called it vibe engineering. Yeah, we don't know how we feel about the whole vibe thing, really. But yeah, packing capability is skills, absolutely critical. So look at what Claude have done with skills. Anthropic have done with skills, how they've built them, how they've defined them. They've put out so much stuff publicly about that. And he's saying, start to write your own skills. In the same way, we have been for things like Alexa and Google and so on. Then think about how you're designing your loop to use those skills. Making sure that it's working in a traditional structured way. What's your goal? Plan it, run your tools, test, diff, retry, PR. Standard type of stuff still. A really interesting finding as well in terms of what we've been talking about today. He's finding that often the CLI and the tool's capabilities with the CLI is actually beating out MTP when you're looping. And it's cheaper in terms of your token use. So those Microsoft guys on Amplify, they're burning thousands of dollars a day on tokens. Simon's not going to be doing that. He's going to be doing this in a really tight, really focused way and parsimonious way. Parallel stuff where the review is cheap and it's safe to do so within a sandboxed environment, so you can come back after all the parallel runs and find what's good. And always sandbox or you don't do it. Safe environments. Claude just announced their sandbox product within the last few days. Okay, so where might all of this be going and where are we going with it? Well, we've gone from manual coding through to some assisted coding, tab to complete, etc. And we're now getting into structured coding, leading towards agentic and governed. For us, I think that looks like making pipelines and agents for our hand-cranked PMO processes, the stuff that I've been doing for myself to automate my own role and the people around me. And then testing a kind of hybrid of the Spark approach and the DEFRA approach, I think is going to work well for us. And then sharing that learning, really importantly, through the AI and Technology Working Group at the WLGA that I'm involved with, through the Centre for Digital Public Services and others. Get it out there, make it public, keep the value in the public sector as well. For larger teams, which you guys will all be, a lot of you will be from larger teams. So it's about aligning with standards and what's already out there within government and so on, and creating something that fits your environment at enterprise scale, of course. Next evolution is going to be benchmarking all of this, full CI/CD agents with the human oversight side of things, agreeing on those benchmarks. How do we get those new standards that we need? Do we need standardized and shared evaluation harnessing, for example, in central platforms that we can all make use of? And I think finally, Wales needs something really similar to this, but it's not going to be exactly the same because it's got unique challenges, got a different legislative environment, and we've got the Welsh language and its statutory protection to consider, of course. So, in conclusion, structure and standards, vitally important, of course. Got to share the learning, get it out there, keep it in the public domain. Public learning is so important. It's faster to do that now as well. Our skills, your skills, my skills, they're more important than ever. But the way in which we use them, the way in which we apply them might change, and we should be ready for that. And just thereby, in order to do that, we'll need to experiment responsibly. But it's exciting, there's a really bright future ahead. We can do an awful lot of good stuff even quicker now with these new tools. In doing that, it's absolutely vital that we look after ourselves, we look after people, whether they're our customers, our service users, or our teams. Got to keep people at the forefront and people-focused outcomes at the forefront. And finally, enjoy it. Have fun with it. Because that way you learn and we can all still have a productive future. Great. That's it. Thank you. Diolch yn fawr, everybody. Thank you very much.